Self-Rekha Varyanyan, Yogeshwari Mahavidyalaya, Ambajogai. Now we are going to study about integration by partial fraction. We know the definition of a rational function. If f of x and g of x are two polynomials, then f of x divided by g of x, where g of x is not equal to 0, means denominator is non-zero, is called a rational function of x. We know the definition of rational function. If f of x and g of x are two polynomials, then f of x divided by g of x, where g of x is not equal to 0, is called a rational function of x. It is also called a rational algebraic function of x. Now there are two conditions. If degree of the numerator f of x is less than g of x, if degree of f of x is less than degree of g of x, then f of x upon g of x is called proper rational function. Proper rational function. If degree of f of x, which is greater than or equal to degree of g of x, then f of x upon g of x can be written as quotient plus remainder divided by g of x. It is also written as q of x plus r of x divided by g of x. Then r of x divided by g of x is called a proper rational function. Now we want to find the integration of such type of function. Then integrand function can be expressed in the form of rational form. Then these rational forms can be written in partial fraction form. So how we can write it? If the integrand function contains the rational form px plus q upon x minus a into x minus b, then this can be written as a upon x minus a plus b upon x minus b. If the integrand function is in the form of rational function, that is px square plus qx plus r upon x minus a into x minus b into x minus c, then this can be expressed in partial fraction form a divided by x minus a plus b divided by x minus b plus c divided by x minus c. Now third form, these two forms are non-repeated linear factors. Now this is repeated linear factors. and this is non-repeated linear and quadratic factors. So here third form, px plus q divided by x minus a bracket square, degree of the numerator is less than degree of denominator, then this can be expressed as a upon x minus a plus b upon x minus a bracket square. Px square plus qx plus 4 divided by x minus a bracket square into x minus b can be written as a divided by x minus a plus b divided by x minus a bracket square plus c divided by x minus b. Now next form, integrand function contain the rational form px square plus qx plus r upon x minus a bracket cube into x minus b, repeated and non-repeated linear factors here. So this can be expressed in the form of a divided by x minus a plus b divided by x minus a bracket square plus c divided by x minus a bracket cube plus d divided by x minus b. Now we are going to take non-repeated and non-repeated linear and quadratic factors. This is the form, rational form px square plus qx plus r upon x minus a into x square plus bx plus c. So this can be written as a upon x minus a plus bx plus c upon x square plus bx plus c. If the denominator contain the quadratic factor, then numerator we will take bx plus c. So these are the different rational forms. Integrand function is in the form of rational function, then it can be reduced in the form of partial fraction form. It is called the partial fraction. Here these first and second function is non-repeated linear factors. Third, fourth and sixth are non-repeated and repeated. Third is repeated only factors, and fourth and sixth are repeated and non-repeated linear factors, and fifth non-repeated linear and quadratic factors. In all these forms, degree of the numerator is less than degree of the denominator. If the degree of the numerator is greater than or equal to degree of the denominator, then the function can be written as quotient plus remainder upon g of x, and this function can be written in all these 6 forms. Now we are going to take the examples on it. Examples. Evaluate integral of integral of 4x upon 2x square plus x minus 1 dx. Now we want to find the solution of this example. This is the function is in the form of px plus q upon ax square plus bx plus c, and we know how we can solve it by taking the coefficient of x square common and add and subtract the perfect square and reduce this function in the form of special integral form and find the integration. But now we are going to study about the integration by partial fraction. Means we apply this here, integration by partial fraction method. So how we can apply it? So solution, let I is equal to this function. Now we are going to take the factors. 2 into minus 1, minus 2. We will take the factors of minus 2, whose the product is minus 2 but sum is 1. So we get 2 into minus 1. So 2 minus 1 become 1. So this can be written as integral of 4x upon 2x square plus 2x minus x minus 1 dx. Now this can be written as integral of 4x upon 2x into x plus 1 minus 1 into x plus 1 dx. Now this can be written as integral of 4x upon x plus 1 into 2x minus 1 into dx. Now this is in the first form. Here non-repeated linear factors. There are two non-repeated linear factors. This is the rational form. Now we want to write this in partial fraction form. Now 4x divided by x plus 1 into 2x minus 1 is equal to a divided by x plus 1 plus b divided by 2x minus 1. Now we want to find the value of a and b. So multiply by x plus 1 into 2x minus 1. We get 4x is equal to a into 2x minus 1 plus b into x plus 1. Now simplify this. We get 2a plus b into x plus minus a plus b. Collect the terms. Multiply by a to first bracket and multiply by b to second bracket and collect the terms which contain x and constant term. Now by equality, by equating coefficient of x and constant. So we get 2a plus b is equal to 4 minus a plus b is equal to 0. There is no constant in left hand side. Then 4x plus 0. 4x can be written as 4x plus 0. Now solving equation 1 and 2. Solving equation 1 and 2. We get subtracting these two equations, we get 3a is equal to 4. Therefore a is equal to 4 by 3. Substitute and b is equal to 4 by 3. B is equal to a. Value of a is 4 by 3. Therefore I can be written as integral of 4 by 3 upon x plus 1 plus 4 by 3 upon 2x minus 1 into dx. Now write down the separate integral. 4 by 3 into integral of 1 upon x plus 1 dx plus 4 by 3 into integral of 1 upon 2x minus 1 dx. Now we want to simplify this function. We get 4 by 3 into log of x plus 1 plus 4 by 3 into log of 2x minus 1 divide by coefficient of x is 2 plus c, and this can be written as 4 by 3 into log of x plus 1 plus 2 by 3 into log of 2x minus 1 plus c. So this is the integration of this function. This is the solution of this example. Now we are going to take next type of example. Next. Next example, integral of x square plus 2 divided by x minus 1 into x plus 2 into x plus 3 dx. Now we want to solve this example. Integrand function is in the form of a rational function and denominator contains the product of non-repeated linear factors. Then we want to find the solution of this example. Let I is equal to this function. Now x square plus 2 divided by x minus 1 into x plus 2 into x plus 3 can be written as a divided by x minus 1 plus b divided by x plus 2 plus c divided by x plus 3. We want to find the value of a, b, c by using direct method also. Now, but we find here previous method. Now, x square plus 2 is equal to a into x plus 2 into x plus 3 plus b into x minus 1 into x plus 3 plus c into x minus 1 into x plus 2. Now, for x is equal to 1, second method. First partial fraction is a upon x minus 1, for which value the denominator becomes 0. For x is equal to 1, so x minus 1 becomes 0. So we substitute x is equal to 1, we get 1 square 1 plus 2 is equal to a into 1 plus 2 into 1 plus 3 plus 0 plus 0. Function contain x minus 1, then 1 minus 1 becomes 0, 0 into b becomes 0, 0 into any function becomes 0. We get 3 is equal to 3 into 4, 12a. Therefore, a is equal to 1 by 4. Now for x is equal to second partial fraction is b upon x plus 2, then we take the value of x for which value the denominator becomes 0. So x is equal to minus 2. Therefore, minus 2 square plus 2 is equal to 0 plus b into minus 2 minus 1 into minus 2 plus 3 plus 0 factor which contain x plus 2, that terms become 0. Minus 2 plus 2 becomes 0. So we get this function 6 is equal to minus 3 into 1 means minus 3b. Therefore, b is equal to minus 2. Now we want to find the third constant, that is the c. So how we can find it? For x is equal to, denominator becomes 0 for x is equal to minus 3. Minus 3 square plus 2 is equal to 0 plus 0 plus c into minus 3 minus 1 into minus 3 plus 2. Here x plus 3 minus 3 plus 3 0, 0 into any function 0, 0 into any function 0. So we get 11 is equal to minus 4 into minus 1 4c. Therefore, c is equal to 11 by 4. Therefore, the given integral function can be written as a. Value of a is 1 by 4. 1 by 4 upon x minus 1 plus value of b is minus 2. Minus 2 upon x plus 2. b upon x plus 2 plus c, and value of c is 11 by 4 upon x plus 3 dx. So the rational function can be written in this form. Write down the separate. 1 by 4 into integral of 1 upon x minus 1 dx minus 2 constant taking outside 1 upon x plus 2 dx plus 11 by 4 into integral of 1 upon x plus 3 dx. Now integration of this function is 1 by 4 into log of x minus 1 minus 2 into log of x plus 2 plus 11 by 4 into log of x plus 3 plus c. So this is the integration of given function. We can find the values of a, b, c by using this method or by using the previous method. We solved the previous example by using another method, and here we solve this example by using this method. There is also the third method. Next example, integral of 1 upon x into x minus 2 into x minus 4 dx. We want to solve this example by using integration by partial fraction. So how we can solve it? So this is also in the form of non-repeated linear factors. Let I is equal to given function. Now 1 upon x into x minus 2 into x minus 4 can be written as a upon x plus b upon second factor x minus 2 plus c upon third factor x minus 4. Now we want to find the value of a, b and c. So how we can find the values of a, b, c? Now this can be written as, here a is equal to, we are going to take the third method now. So for third method, a is equal to 1 upon x minus 2 into x minus 4 at x is equal to 0. Here first partial fraction is a upon x. So the denominator of first partial fraction is 0 for which value? So x is equal to 0. So we will take except the first non-linear factor, we will take the LHS of this function and we get 1 upon 0 minus 2 into 0 minus 4, we get 1 upon 8. Now for b, which is the denominator of second partial fraction, x minus 2, except x minus 2 we take the LHS function 1 upon x into x minus 4, and for which value the second partial fractions denominator becomes 0, x is equal to 2, we get 1 upon 2 into 2 minus 4, we get minus 1 upon 4. C is equal to third partial fraction contain the denominator x minus 4, except x minus 4 we take 1 upon x into x minus 2, at which value denominator 0, so 4, we get 1 upon 4 into 4 minus 2, we get 1 upon 8. So integral function can be written as in this form: a upon 1 by 8 upon x plus minus 1 by 4 upon x minus 2 plus 1 by 8 upon x plus x minus 4 dx. So we get separate integral 1 by 8 into integral of 1 by x into x minus 1 by 4 into integral of 1 upon x minus 2 into dx plus 1 by 8 into integral of 1 upon x minus 4 dx. We get 1 by 8 into log x minus 1 by 4 into log of x minus 2 plus 1 by 8 into log of x minus 4 plus c. So this is the integration of this function by using different methods. There are 3 methods. Which one is easy? So you can try to solve this example by using that method. Now from next problem we are going to take only one method. We will take second method or this third method. Next example, evaluate integral of x square plus x minus 1 divided by x square plus x plus 6 minus 6 dx. Now we want to solve this example by using integration by partial fraction. Here degree of the numerator is equal to degree of the denominator. Then we solve this example by using actual division method, but here we adjust function because two terms are same, only adjust the constant. We get this can be written as x square plus x minus 6 plus 5 divided by x square plus x minus 6 dx. Now this can be written as integral of 1 plus 5 upon x square plus x minus 6 into dx. Now separate divide. So we get this function. Now this can be written as integral of 1 dx plus 5 into integral of, or 5 upon x square plus x minus 6. What is the factor of x square plus x minus 6? X plus 3 into x minus 2 into dx. Now we want to find, we write this function 5 upon x plus 3 into x minus 2 can be written as a upon x plus 3 plus b upon x minus 2. So this can be written as 5 is equal to a into x minus 2 plus b into x plus 3. Now we want to find the value of a and b for put x is equal to first denominator 0 for minus 3, we get 5 is equal to a into minus 3 minus 2. So 5 is equal to minus 5a, therefore a is equal to minus 1. Now we want to find the value of b. For that, put x is equal to second partial fractions denominator become 0 for x is equal to 2. We get 5 is equal to 0 plus b into 2 plus 3. Therefore, b is equal to 1. Therefore, I can be written as integral of 1 dx plus integral of a upon x plus 3 minus 1 upon x plus 3 plus 1 upon x plus 2 into dx. So this can be written as integral of 1 dx plus minus integral of 1 upon x plus 3 dx plus integral of 1 upon x plus 2 dx. So we want to take the integration of this function, and integral of 1 dx is x minus log of x plus 3 plus log of x plus 2 plus c. This is the answer, and this can be also written as x plus log of x plus 2 divided by x plus 3 plus c. When we solve this example, same type of example, by using the adding and subtracting the perfect square term, this is the quadratic equation, coefficient of x square is 1, then add and subtract the perfect square term and we get the answer is in this form. When we solve by using perfect square method, then we get this answer, and when we solve by using the partial fraction, then we get this answer. Both are same. There will be small change only here. Next type of example. Different type of example. We want to solve this example by using substitution. Integral of 2x square minus 1 divided by x square plus 4 into x square plus 5 dx. Now I want to solve this example. So by using the substitution method, this is the exceptional case here. In this example, we substitute t t is equal to x square. Then integrand function 2x square minus 1 upon x square plus 4 into x square plus 5 can be written as 2t minus 1 upon t plus 4 into t plus 5. So this is in the form of non-repeated linear factors. Now we want to solve this example. 2t minus 1 upon t plus 4 into t plus 5 is equal to a divided by t plus 4 plus b divided by t plus 5. So 2t minus 1 is equal to a into t plus 5 multiply by t plus 4 into t plus 5, we get this function plus b into t plus 4. We want to find the value of a. For finding the value of a, put t is equal to minus 4. 2 into minus 4 minus 1 is equal to a into minus 4 plus 5. We get minus 9 is equal to a. Now put or for x is equal to minus 5. 2 into minus 5 minus 1 is equal to a into minus 5 plus 5 becomes 0 plus b into minus 5 plus 4. We get minus 11 is equal to minus b. Therefore, b is equal to 11. The value of a is minus 9 and value of b is 11. Now simplify this. I can be written as integral of a upon a is minus 9 upon t plus 4. Value of t is x square plus 4 plus value of b is 11 upon t plus 5. Value of t is x square plus 5 into dx. Now write down the separate integration. Minus 9 into integral of 1 upon x square plus 4 dx plus 11 into integral of 1 upon x square plus 5 into dx. So this can be written as minus 9 into integral of dx upon x square plus 2 square plus 11 into integral of dx upon x square plus root 5 square. By using the integration special integral function, we find the integral of dx upon x square plus a square is 1 by a into tan inverse of x by a minus 9 into 1 by a 2 into tan inverse of x by a x by 2 plus 11 into 1 by a is root 5 into tan inverse of x by root 5 plus c. So this can be written as minus 9 by 2 into tan inverse of x by 2 plus 11 by root 5 into tan inverse of x by root 5 plus c. So this is the solution of this example. So